Alright guys, welcome back to 10.2, our very last lesson of algebra for the whole year ever together. Crazy. So sad, but also so fun. Congratulations, we've made it to the end. Alright, let's look at 10.2 together. Solving quadratic equations by graphing. Starting right here, recall that a quadratic equation has standard form. It's in the form of f of x equals ax squared plus bx plus c. And again, remember we're going into function form. Function form just has that f of x instead of y, but it still represents y. They're really the same thing. In a quadratic equation, the value of the related function is 0. So they're saying you can sub in a 0 right here to make this equation set equal to 0, just as we did with factoring to solve for our unknown values. So the equation is really, so for the equation 0 is equal to x squared minus 2x minus 3, the related quadratic function is f of x is equal to 2x minus, or x squared minus 2x minus 3. So here they have the f of x, and then they're saying the related function is a 0, so you can just change it to a 0 if you want. You have used factoring to solve equations like this before. You can also use graphing to determine the solutions of an equation. The solutions of a quadratic equation are called roots of the equation. The roots of the quadratic equation can be found by finding the x-intercepts or the zeros of the related quadratic function. So looking at example 1, 2 roots. We're going to be doing some factoring to be able to state what our values are, and they're going to go through a bunch of information really quickly that we're going to try to discern over here. So they're saying solve x squared plus 6x minus 7 is equal to 0 by graphing. So that means state what x is equal to, but they also want you to graph it. So let's read through it first. The graph the related function f of x is equal to x squared minus 6x minus 7. Don't super worry about what that means. It's just a y. So they're saying rather than this being set equal to 0, pretend it's set equal to y, and then you're used to graphing something like that. The equation of the axis of symmetry is, so remember from yesterday, our axis of symmetry, so axis of symmetry, I'm always bad at doing acronyms, is equal to negative b over 2a. So they say your axis of symmetry is x is equal to negative 6 over 2a. How did they get that? Well, what's your b value in this equation? Your b value is 6. So your axis of symmetry is equal to negative whatever your b value is, which was 6, over 2 times whatever your a value was. Well, your a value was positive 1. So that's how they got this equation so quickly. Negative 6 over 2 is equal to negative 3. So your axis of symmetry is x is equal to negative 3. But again, we don't have our vertex yet. We just have the first part of our axis of symmetry. Now they say, when x equals negative 3, f of x, the equation equals, so they're using f of x in terms of y. So y equals negative 3 squared plus 6 times negative 3 times 7, or negative 16. So again, they're very quickly getting the vertex for you. Remember, your vertex is equal to whatever your x value is plugged back into your original equation. So my original equation was f of x is equal to x squared plus 6x minus 7 is equal to 0. And now they're saying in order to solve for f of x, which is just your y value, all you have to do is plug in x here to solve for y. So you plug in your negative 3. Negative 3 squared plus 6 times negative 3 minus 7, and that's going to be our y value, if you will. Once you do that, negative 3 squared is going to be positive 9. 9 plus 18, negative 18, minus 7 and you're going to get y equals 16. So now that I have my x for my axis of symmetry and my y value, I know my vertex is equal to -3, 16. And because this whole graph is positive, I know I'm going to have a U-shaped graph, which means my lowest point on this whole graph, my minimum value, is going to be 3, 16. So the coordinates of the vertex are -3, -16. Whoops. Make a table of values to find the other points on the sketch. And so now they did the values, -8 all the way through +2, and then they graph this beautiful parabola. They say now, to solve x squared plus 6x minus 7 equals 0, you need to know where the value f of x is equal to 0. This occurs at the x-intercepts. So where is y equal to 0? Well, again, think back to finding intercepts. Where y is equal to 0, you say let y equal 0, and you use that to find your x-intercepts. On your x-intercept, y is equal to 0, and you have a numerical value for x. So this occurs at the x-intercept. The x-intercept of the parabola appears to be 1 and -7. And now we're going to look at how you actually solve that. So we're saying, I know my parabola is going to make this dip, but a really quick way to graph this would be if I can identify my vertex and then identify my roots, also called my zeros, which is just my x-intercepts. So how can I find these x-intercepts? Flip the page and stay tuned. They're saying the best way to find your x-intercepts is simply to factor it. So our original problem, again, was x squared plus 6x minus 7, and then we set it equal to 0 because we're told we can do that. Well, what are my factors of -7? That's sum to +6, so it's going to be 7 and -1. So I have the factors x plus 7, x minus 1 equals 0. Solve for x equals -7, x equals +1. So I'm saying my parabola, my beautiful U-shaped graph, is going to intersect my x-axis at -7 and +1. And looky there, I intersect at -7, +1. And from this part, I had already graphed my vertex. So it's a really fast way of saying, okay, point 1, point 2, point 3, now I have the bare minimum sketch. So that's the value of roots. It's just saying, where does it intersect my x-axis? Moving on to example 2. Quadratic equations always have two roots. Again, -7, +1. However, these roots are not always two distinct numbers. Sometimes the two roots are the same number. Boom, boom. Looking at example 2. Looking at example 2. Solve b squared plus 4b is equal to -4 by graphing. Then it tells us first write the equation so one of the sides is equal to 0. So I'm just going to add 4 over here. That way I have one side set equal to 0. There's nothing I can combine, so I'm just going to end up with a new term. B squared plus 4b plus 4 is equal to 0. Now they say graph the related function. And so again, once you have the 0, it's interchangeable with f of x, in this case f of b, or really y. So just because the 0 is here, you can still say, okay, I'm going to plug in a b value, and once I do that, it's really going to tell me my y value. So they make a table of values. So again, this is now a mess. It's either 0 or it's your y value. It's 0 when you want to factor, and it's your y when you're looking for your ordered pair. So they, for example, plug in -4 for b to be able to graph this with all of their points. So they say, let b equal -4. So -4 squared plus -4 times 4 plus 4. That's a lot of 4s. And now it's set equal to 0 again, or y, but it's really y, so that we can figure out our x and y value to graph it. So -4 squared is +16. +16 minus 16 cancels out. and I'm left with 0, or 4. 4 equals y. So in this particular case, my ordered pair is now going to be -4, comma 4, because that's what I was left with. And that's how they filled in this table. They just started, let b equal -3, boom, 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 boom. Get an answer, whatever that answer is your y value. Plug in -2 for b, once you get an answer, that's your y value, so on and so forth. That's, again, how they got these table of values. But then they want you to graph the roots. That's really what we're looking for. So it says, notice that the vertex of the parabola is the b-intercept. So the vertex of the parabola is that very minimum point right here. But they're using b instead of the letter x because they're being annoying. But they say, notice that the vertex is the b-intercept, which is the same thing as your x-intercept. The vertex is where it's hitting my x-axis. Thus, one solution is -2. So what's my vertex? 1, 2. It's -2. What's the other solution? So they're saying, we already said you always have two solutions, but this graph is only hitting my x-axis at one point. My vertex is on it, rather than my vertex being below it and my U-shape coming up and hitting it. Well, what do? You factor it. So this is when I'm going to set it equal to 0, not y, but I have b squared plus 4b plus 4 is equal to 0. What are my factors of 4 that sum to 4? Well, 2 and 2. So I end up with the terms b plus 2, b plus 2 again, is set equal to 0. So what are my factors? B is equal to -2. And it's both of them. This is b is equal to -2, and this is b equals -2. So while I only have one point that it intersects on the vertex, I really did get two answers. They're just repeating answers. So there are two identical factors for the quadratic function. So there is only one root called a double root, and the solution is -2. So our solution, again, is -2, and we call it a double root because when you factor your quadratic, you get the double answer of -2, -2. So there's only one root, but it's a double root. Now moving on, what happens when you have no roots? Thus far you've seen the quadratic equations can have two roots or one double root, but can a quadratic equation have no roots? Solve x squared minus x plus 4 equals 0 by graphing. So example 3. We're told to solve this by graphing. X squared minus x plus 4 equals 0. Well, rather than it being 0, we're going to have that set equal to that y again. And you can plug in any value. Let's plug in -1 for x minus 1. There we go. Plus 4 equals y. So what's our x and y value going to be? Well, when x is -1, -1 squared is +1. A negative is a positive here, so we get +1 plus +1 plus 4 is going to be 6. So again, when x is -1, y is 6. Repeat that with 0. 0 squared minus 0 plus 4 equals 0. Cancels. When x is 0, y is 4. We'll do one more. We'll do +1. So 1 squared minus 1 plus 4 equals our y value again. 1 squared is 1, 1 minus 1 is 0, 0 plus 4 is 4. This is the point of interest. We now have two of the same y values. And I said that was going to be the last one, but we're going to finish that with the number 2. So 2 squared minus 2 plus 4 equals y. 2 squared is 4. 4 minus 2 is 2. 2 plus 4 is 6. Y equals 6. That's our ordered pair. And so you can see that they've gone ahead and graphed it here. And you notice in your graph, if you're looking in your book as well, that there is no x-intercept. This particular graph does not hit your x-intercept at all. It's too far up on your y. The graph has no x-intercept, thus there are no real number solutions for this equation. The symbol open set indicates it's an empty set. So there are no real roots. Again, you could still graph this, but if your problem said, what are the roots to this particular problem? Roots equal nothing. While it's still graphable, your roots are just wherever your parabola hits your x-intercept, and this particular graph is never going to hit. All right, we're going to go ahead and stop there with example 3. Congratulations on finishing algebra, and we're done, guys. Good job.